Welcome everyone to today's webinar. This is Maria Blaise Costello, and I'm happy to welcome you to a Clean Energy Group webinar as part of its Resilient Power project. And today's webinar topic is Resilient Power Retrofit, how a Minnesota Nature Center became a solar+storage community shelter. So we're going to give everyone just a couple more seconds here to log on, and then we'll go over a housekeeping slide and get started. Okay, so to keep us on track, I'm going to start. This is Maria Blaise Costello. Again, welcome to all you have joined us today for today's Resilient Power webinar brought to you by the Clean Energy Group. A quick housekeeping slide as we start today's event. You'll see on your webinar console that you can access the audio portion of today's webinar either through your telephone or your mic and speakers. And no matter which technology you use, you will be on a listen-only mode, so we will not be able to hear you. We hope that you will have questions which you can submit at any time during today's presentation, and we're going to ask that you please type up your questions in the question box that you'll see there and then hit send. They will be sent to Seth Mullendor, who will be the moderator for the Q&A session at the end of the presentation, but whenever you have a question, please feel free to type it in and hit send. This webinar is being recorded, and it will be made available after today's presentation on the Clean Energy Group's website. You can find it at www.cleanegroup.org or on the Resilient Power project page at www.resilient-power.org. So this webinar, as well as a slew of other webinars we've done over the past 2 years, are all archived there. So with that, what I'd like to do is hand this over to Seth Mullendor. Seth is the project director for the Resilient Power project at Clean Energy Group. So Seth, please go ahead.
Thank you, Maria, and thank you everyone for joining us today. I'm just going to give you a quick introduction about who we are here at Clean Energy Group before turning it over to today's presenters. Clean Energy Group is a national nonprofit that works among a number of clean energy technologies, doing innovation in finance, technology, and policy. We started the Resilient Power project about 3 years ago with the Meridian Institute, and the project is supported by several foundations: JPB, Bar Foundation, Nathan Cummings, Kresge, and CERDNA. We also have a sister organization, the Clean Energy States Alliance, which is a organization that is state clean energy program administrators across the country. Next slide, please. So just to tell you a little bit more about what the Resilient Power Project is, basically the project was formed in the wake of Superstorm Sandy when there were mass outages across the Northeast, looking for a better way to provide backup power, critical power to serve people's needs when there is a critical outage like this. Basically, the Resilient Power Project uses mainly solar and storage and the combined technologies to provide a reliable, clean energy solution to provide resilient power. We're looking to increase public and private support of these systems and increase awareness on all levels. We work with people at the state level, federal, city officials, as well as individual developers. The project, through our foundation support, we have a specific focus on bringing these technologies and these solutions to low-income and other vulnerable communities. Specifically, we work a lot with affordable housing, multifamily housing, as well as critical public facilities that support these communities, whether that's emergency shelters, police and fire stations, healthcare centers, and the like. We advocate at the state and federal level for supportive policies and programs to get more resilient power projects out there. We also write a lot of reports and get a lot of information out there through webinars, blogs, and things of that nature, which you can find on our website. We do have a small technical assistance fund that can help support some of the pre-development costs for individual projects to help get them going and figure out the technical and financial feasibility of projects to get them started. So next slide. This is just a snapshot of our website, resilient-power.org. We have a lot of resources there for anyone that's interested in resilient power, interested in solar and storage, or looking to develop a resilient power project. In addition to these webinars, which were recorded and available on the website, we have a number of reports and blogs, some weekly and monthly newsletters, as well as resources such as a project map that shows resilient power projects across the country, and featured projects and resources for developers. So with that, next slide, I will introduce our presenters for today. We have a couple of people that were really influential in getting this project done in Duluth, Minnesota. This is an exciting resilient power project done there. So first off, we have Brett Pence with Equilibrium 3. Brett is a program specialist there. Equilibrium 3 is a nonprofit based in Duluth that has a focus on sustainability through local energy production and community development. He currently administers their Solar Market Pathways grant with the Department of Energy, and it's a 3-year project to reduce the cost of solar locally and move Duluth forward in the use of local solar resources. He also assists in administering the DEEP and Giving Comfort at Home programs. It's a residential energy efficiency audit service and low-income energy assistance platform. So Brett and Equilibrium 3 were very influential in facilitating and getting this project put together. We also have from the University of Minnesota Duluth, we have Allison Hoxie. Dr. Allison Hoxie is an assistant professor at the University of Minnesota Duluth in Mechanical and Industrial Engineering Department. She has an education with a Bachelor's of Arts in Natural Sciences from the College of St. Benedict and a Bachelor of Science in Mechanical Engineering and PhD from the University of Minnesota Twin Cities. She has held positions in the past as a consulting engineer in the power and energy sector and as an instructor at the University of Utah. Her work is published in the journals Fuel, Renewable Energy, as well as the Journal of Propulsion and Power. Her current research focuses on cost-effective methods for efficient utilization of biomass-derived oils and in combustion applications. So I'm going to turn it over to Brett and Allison now. As Maria said, please enter your questions if you have them, and we'll address them at the end. Thank you.
Thanks, Seth. My name is, again, Brett Pence with Equilibrium 3, and Allison and I are really happy to be presenting this topic to you today. What we're going to try and take you on a journey with us and tell you how we went from a nature center that had a solar installation that was in need of repair, and took that from a repair project to a storage retrofit with resiliency and economic and educational values attached to it. So we'll be going through that, but at the before that, we'll introduce ourselves a little more here. Pardon me, let me go back. Okay, Allison?
So, as was mentioned, we're located in Duluth, Minnesota, which sits on Lake Superior. So a couple of things that are good to know about Duluth. It's quite cold here. We basically sit on the edge of a huge thermal reservoir that's, at about 50 degrees Fahrenheit. And our city was really a port city that ships a lot of natural resources out of our area and a big steel community, and we're really transitioning now to more tourism and a new sort of education, healthcare, a new economy, and part of that is a transition in energy as well. We have a mayor that's very committed to changing our energy infrastructure, a university that's really committed to that as well. So this project fit in great into this community.
Yeah, and in terms of Equilibrium 3, again, that's where I work. It's a nonprofit. I think Seth did a good introduction. In terms of solar market pathways and what we're trying to do there, solar is really a nascent resource in Duluth. Hasn't been used a lot in the past comparative to other places. And so part of what we've been trying to do with solar market pathways is find out what has happened historically in terms of solar, identify those barriers, then develop pathways around those barriers or just surmount them to put more solar on the ground. And we really felt that storage was one of those ways to get at a barrier that we saw in terms of small commercial, where people couldn't get their demand charges met with solar up here. and also in the municipal side. And then also in terms of other people looking for resiliency features with solar and with grid-tied solar, as most of you know, grid-tied solar doesn't traditionally, at least in the last 10 years, hasn't provided those kind of resiliency features that something with full battery backup has in the past. So we really liked the idea of this project. Excuse me?
The University of Minnesota Duluth is a regional comprehensive university, and it is a land-grant university, so one of our missions really is technology transfer. And I have worked with Equilibrium 3 on some previous projects, and so when this project came up, they contacted me, and it was a great opportunity for something like that to occur. We have about 11,000 students, mostly undergrads, a few graduate programs, and over 500 full-time faculty.
In terms of the project itself, Hartley Nature Center, and you saw a picture at the beginning of the presentation of the building, but it's a kind of a unique situation. The building was built in 2003. It is a city-owned building, but it houses a nonprofit, which is also called Hartley Nature Center, which is an environmental education nonprofit. The building itself was designed to be a net zero building, and so it was designed with not only solar but ground source heat pumps and high degrees of air sealing and insulation. The center sits within a 600-acre park on the east side of the City of Duluth. It is a center for, again, outdoor education and a preschool, and it is a focal point of the community recreationally as well, and you can see the numbers there that come through. It has also been a showcase for energy because of its design.
So I just want to give you a little bit of a project overview. Back, as Brett said, this building was originally designed to be a net zero building. The first installation of the PV system was back in 2002, 2003. And they have an 11 kilowatt array on the roof and a 2 kilowatt ground mounted dual axis tracker near the parking lot. This system originally had 6 inverters in it, and they started to fail in the last few years, and by 2016, 4 out of those 5 roof inverters were no longer operable. So they basically had a repair project on their hands that the Nature Center, the nonprofit, was responsible for. And they had estimated that the cost would be around $10,000 to replace all those inverters with 2 new inverters and all the rewiring. So the project really started as an opportunity where something needed to be repaired in the system, but there was an opportunity to add some added value to the nonprofit and to the building. So the idea of a battery came about, and we sort of just started to build the team around the idea of changing this project into a retrofit plus storage project. This all is happening simultaneously as the Nature Center itself is upgrading its lighting to moving to LEDs and also putting in a new ground source heat pump that had failed. So when we first started the project and started looking at the energy data, everything was failing. So we didn't have a really great sense right away what the energy use that the building would have with new systems.
This is just an outline of how the project happened. In talking to Seth about this in Clean Energy Group, I think one of the things he really wanted us to focus on is process, particularly how this team came together and how the funding happened. I don't have a timeline here, but we first started talking about this project as a team in January or February of this year, and the battery is installed at this point, although it's not running autonomously right now because we're waiting for some parts, so we'll get to that. But it was actually installed, and we had a commissioning party on August 26th. So it was a pretty quick turnaround. And so I know he wanted me to talk about that. We'll also talk about the technical designs, the class. We did this as an educational continuing ed class for our community as well, and then how we're looking at this in the future in terms of optimizing and monitoring.
So the project team, Brett and I were the co-leads on this project, me being from UMD and Brett from Equilibrium 3. The City of Duluth was a really important partner on the project. Alex Jackson was our contact with the city. We also worked closely with one of the city's electricians. Their master electrician basically did all of the wiring project. Tom O'Rourke is the director of Hartley Nature Center, and Brett Amundsen is director of operations. And so we worked closely with them, of course. Chris LaForge was our technical advisor. He's with Great Northern Solar and was involved in the original installation of the PVs at the site. And Paul Hellstrom from Minnesota Power was a big help on the project as well.
Mm-hmm. Yeah, and I think one thing, before I move to the next slide, another thing to add perhaps about the team that may be unique to other projects is that this team really formed around a need for Hartley to repair its system and to look for other options before we even considered even storage at some point. So we had a very committed team on a number of different levels before we even started looking at funding or different options, which I think is kind of unique. And all of the organizations within it were willing to take some risk to make this work again, and all interested in storage, not even knowing if that was going to be an option. So I think that was kind of unique. In terms of the funding, we had funding from a number of different resources, but the funding that really made probably the most critical piece that made this project real was coming from the University of Minnesota, a regional sustainable development partnership. We received notice that we had that application had been granted in February of this year, and that was $7,000 to put towards the use of this system. At the time, we really didn't know the cost, but we knew we needed a seed grant to make it real, and that provided the seed money for us to go back to other entities that were participating and saying, hey, we have some money, can you match it, are you interested? The other grant that I think, all the grants were very important, but in terms of this actually moving forward, I would say the City of Duluth was also a key partner in the fact that they provided, as Allison said, a lot of the labor, in-kind labor that made this happen. You know, probably the estimate would be $12,000 to $15,000 from the city in terms of their time on this project. They were very interested on a number of levels. One, they wanted this to become a resilient public shelter for folks they could charge their phones and come in and have a dry place to come in an emergency, but also in terms of peak demand shaving, because the city probably pays between 40 to 55% of their bills as peak demand, and so they're very, very interested in how to reduce that. Other groups that were really important, Equilibrium 3 at UMD, we brought at-kind resources in terms of labor. Equilibrium 3, it should be said, my position is funded from Solar Market Pathways, and so we had that behind us. Clean Energy Group provided funding for the educational part of this resource, as well as the technical assistance, and we'll get into that as we kind of go along in the presentation. And then Minnesota Power, their foundation, Minnesota Power is our investor-owned utility in this region, and they have a nonprofit foundation, and that foundation ended up providing about a quarter of the cost of the project as well, which really helped things move forward. It took a lot of stress off trying to find different funding sources. Not included in these funding sources are many other smaller funding sources or regional groups that we worked with. Examples of that would be the local union, electrical union, provided $500 again for the class, which was great. And we also had a chapter of the Isaac Walton League, which is a conservation organization that did they were wonderful. They did an LED replacement of incandescent bulbs inside Hartley, and the rebates that Hartley got from those bulbs from the utility were then applied to this project, and that was over $500 to $700. So again, lots of little ways to try and make up that funding.
So the goals for the project were, of course, to replace the inverters that were no longer working so that Hartley could benefit from the solar panels on the site. But it was also to create a public emergency shelter. So having a place where the community could come and charge their cell phones or have a place to get out of the weather was really important. And, you know, funnily enough, about a week before the battery arrived at the site, we had a terrible, terrible storm here this summer, and Hartley was without power for over a week, and most of the community was without power for over a week. So and many of us went into this thinking, well, the grid doesn't go down very often, and then right before that, you know, we've had one of our biggest grid outages in the community. Hartley, we would really like to see the building also move to being an actual net zero building. We think it has the potential to, and this system should help us get there. And then, of course, the storage component is really important. There's not very many storage projects in our area. In fact, this may be one of the first retrofit solar+storage projects in the Midwest. So, and anytime you have a demonstration project, so many unforeseen things that you learn that really aid and educate you on future projects. But also with this project, one thing that's exciting is we're just really excited to see how it performs, how we're able to create some behind-the-meter savings through peak demand shaving and extending our kilowatt hours use. And again, you know, the educational component of this is really important with partnering with UMD. In fact, in the room we have two UMD students here who are learning about the project and are going to be working on the project in coming months. But then also educating the community is a big component of this project.
Mm-hmm. And I would say before a lot of these projects could go forward, just to add to what Allison just said in terms of education, before really a commercial entity could take on the risk of putting this on, someone really had to show them what, you know, if this could work here and what risks they had to look at. So we felt this was a trailblazing project, and we hope to be able to share this in a very broad way with the city, with the commercial community, and many other entities. In terms of how we selected the battery, we looked at a number of different things. The first thing we did is we did realize that because we were interested in peak demand shaving, that a lithium-ion battery was probably, and we had a fairly small place to put the battery and a fairly small load. In fact, the load of Hartley, although it's rated commercial in terms of its utility bills, it might be considered a really large residential load. And so we thought, in talking to different experts, that lithium-ion was going to be where we were going to be looking in terms of energy storage. We know there are other options out there, but for this facility, that seemed to work. As we looked in the lithium-ion sector, one of the things that was that became quickly known to us that was going to be a challenge was that we wanted to do peak demand shaving, which is a commercial application, but we wanted the size of the battery to be basically a large residential battery, and so finding that mix was difficult. Tesla we were very interested in and wrote our original grant on Tesla, but in the end we really couldn't get a lot of information from Tesla and had not enough knowledge about the product, but not enough certainty that we could actually get the product. And so we unfortunately had to count them out, but we'd be interested in seeing where Tesla goes in the future. Juicebox was another one that was very interesting to us, but in the end they did not provide the peak shaving that we really needed. And then we came down to Zonin and Sunverge, which were two great products. We were happy to end up with these two at the end, and we ended up going with the Sunverge product, and we'll talk about why we selected them.
So this is showing you 15-minute data from the utility in January into February and March, and basically this is the beginning data that we had as far as energy use from the building. But like I said, most of the solar panels were not operating at that point because of the inverters being down, and also the ground source heat pump wasn't operating correctly. So it was a ballpark value for us to start with, but we weren't really sure, and we aren't sure yet exactly what the end electrical use is going to be now that we have a new ground source heat pump and the panels are up and running. Mm-hmm.
But if you can see, even in this chart, the maximum kW on a month or in a day in a month would be over 25 or 26 kW. Many of the commercial systems that we were looking at that did peak shaving were started at 24 kW of power, so and they were out of our price range for sure. So we really were operating on some assumptions and had to go with those. So we didn't really have a good measure of what the demand was that we needed, but we definitely started looking at that data. We're also fortunate in that Hartley Nature Center has an e-gauge. That's a power monitoring system that's behind the meter that they installed about 2 years ago. It is an irony that 2 years ago is when their system started failing. So their solar, all the historical data we have collected by e-gauge is after the ground source heat pump also started to fail and the rooftop solar. So, but the advantage of having e-gauge is not only can we see the full consumption and production of the facility, but we can see circuits within that, so we can see what circuits are causing different things to happen. And that's going to really help us as we move through this process, and helped us as we started to select the battery and think about how we wanted to, what amount of demand we wanted to shave. And as you can see on this, some very spiky graphs. That's one thing we learned about in this project, is that they have a water heater that's disconnected from the ground source heat pump because the ground source heat pump failed, but it's causing these demand spikes. And so that's just one example of one thing we found and how we use that to select the battery.
Part of the project was determining what critical loads we wanted to be able to support if the grid goes down. And originally we were thinking of just one schedule for this, but then as we started looking at it and keeping in mind the fact that we just had recently experienced a week of no power, we put this into two categories. One was just what would Hartley want supported if the grid is down for a few hours, say 4 hours or something like that, and then what would the community want or the city want if we had a longer outage where the building became more of a community shelter. And so we went through, Brett and I went through the building and talked with, Hartley talked with the city and asked what they would want, what everybody would want. And we put together this schedule of what would be supported. It turns out, is this a good time to talk about that? Sure. It turns out in reality, this is something that we didn't, we found out as we moved forward with this project, but when you're doing a retrofit, you bring the master electrician in and you find out what things are hooked up together. You don't always get to pick simply what rooms or what outlets you want to have supported and what ones you don't because of the way the wiring is done. And so in the end, we ended up having more on these critical loads than we anticipated and had to go back and sort of cut some of them out. So that was an unforeseen, and it was a real learning exercise for both of us.
Yeah, and I would add to that, it's still ongoing, that we're still working with the electrician and as to what actual loads we can pull in and out of this. The other thing to mention about the critical loads that's different from maybe other projects is that they also have a critter load on here, which other resiliency projects probably do not, but they have as a nature center, they have animals in the building, and some of these animals can do just fine without a power outage and some cannot. And the picture we have here is Billy the bass looking at the camera from his aquarium, and Billy the bass is on the backup, is on the Sunverge battery that's been installed. The other cages were not, and that took some study about, does the animal actually need the power? And so it was a fun thing to work on with Hartley staff on that. So in terms of battery selection, we did end up deciding to go with the Sunverge system. It was the only company to meet our needs. Actually, Zonin and Sunverge both did peak shaving, and both were in our price range of under $20,000, let's say, for the battery. But in terms of Sunverge, it was DC coupled, and Zonin was not. And what that means practically is that an AC coupled system, when you have to replace inverters anyway, you may have two inverters at that point that you have to put in. And that increased the cost enough that wasn't feasible. Also, the Sunverge, the Zonin battery under the 15 kWh storage. It just had some different features, and SunVerge had some additional features that seemed to work well, like energy arbitrage and other things. And they also, SunVerge had some peak demand shading software that was going to be coming out. There was a smart software, and so we just thought it was a better fit. And so we're very pleased having the SunVerge system. Again, the battery is 6 kW in terms of power output and 14.2 kWh in terms of energy storage. But one other thing to mention in terms of the battery selection, so the battery is hooked up to about half of the rooftop array. We still have the other half of the array that needed to be, inverters needed to be repaired, and they needed to be hooked back to the grid. And what we decided to do there was install an inverter, a Sunny Boy inverter that has a secure power supply to it, and that's an outlet where the rooftop array can actually power that outlet if the grid is down with a certain amount of energy. And so that's just going to add to the resiliency features of the emergency shelter, and we're very pleased to see how that works. That was just installed about 2 weeks ago, and we'll be able to kind of test out that secure power supply and see how that can be at best used in a resilient, emergency situations.
For the installation process, we took this as an opportunity to have a class, a continuing education class, to educate our local installers in the community. We'd like to see more of these projects go forward, and so we wanted to have this demonstration project also serve as an educational opportunity. So our technical advisor, Chris LaForge, has taught many of these classes before, and so he set up a curriculum where it was a 4-day class, 2 days and then a week separated, and then two more days. So the first 2 days were spent on troubleshooting the system, Hartley system as a whole, to find out what was wrong with it. So I mean, we already knew and we had already fixed the problem, but we wanted to take the students through the process of troubleshooting. So that was the first 2 days, and then the second 2 days was actually the solution and the installation process of the battery and the new inverters. At the end of that, we had a commissioning ceremony, and I'll let Brett talk a little bit more about how our mayor of our city participated in that.
Well, we had wonderful participation from a number of different groups all through the class. It was really wonderful to see students that were professors, along with electricians, along with policy folks, really taking the class together. So we had a good diversity. But then at the end of the class on August 26th, we had a commissioning party, as Allison mentioned. And as part of that, the mayor spoke, and the mayor of Duluth, Emily Larson, and she made August 26, 2016, Forevermore Solar Storage Awareness Day in Duluth. And it was great to have that kind of recognition of that potential resource in the city, particularly as the city is, again, looking to transform its own energy resources and how it uses energy. In terms of lessons learned, do you want to talk about that, Allison?
Sure. So I think I've been involved with a couple of these demonstration projects, renewable energy demonstration projects, and they're so powerful in educating, future projects. And they're so important because there's always these unforeseen issues that come up that you don't plan for or can't plan for when it's a new project like this that's never been done before. So a couple of things that we learned going through this project is that we ran into some code updates that required some additional safety features that we hadn't anticipated and ended up increasing the cost. Those being the rapid shutdown and the arc fault protection. In fact, the reason that the battery isn't running at the moment is because we're still waiting for a unit that has a combined rapid shutdown and arc fault protection that we're getting like one of the first ever made pieces to put with it. So we're literally waiting for it to be built and shipped to us before we can get the battery up and running. Another thing is that it was really great that we had a contact at Minnesota Power working with Paul Hellstrom, because some of the, the utility hadn't encounteed these storage projects before either, and so they were making decisions about what kind of protection they want to have in case of, you know, a grid outage or something that happens where they need to come and access the building, and whether or not, you know, where shutoff connections are. And we had to convince them that the battery was never going to be, you know, supplying energy to the grid when it shouldn't be. And, you know, if they had gone a different way, it might have created a situation where this project couldn't have moved forward because of cost. And so, you know, having a really good team, a really knowledgeable team when you're doing these projects for the first time is so critical, so that the decisions can get made in a way that don't make future projects economically not feasible to go forward. So even with having said that, you know, our initial project cost estimate was like in the ballpark of $20,000, and we have now ended up with about a $45,000 project. And so I guess we've been fortunate that we've been able to get funding for the large majority of that, and the cost to the Nature Center is still below what it would have been if they'd simply replaced the inverters. And, you know, but there were times in this project where we had to say to the director, we don't know if we're going to get this funding, should we still go, or, you know, is it a red light or a green light? And he, you know, it was great that he was very open-minded and thought the project was a really good project, and sort of took, you know, trusted us and took a leap of faith and let us move forward when all of those pieces were still a little bit up in the air.
Absolutely. In terms of the actual value proposition, Allison mentioned the cost of the project, and we're still finishing the project, although the battery's installed. She mentioned we're waiting for arc fault protection and a rapid shutdown device to come in, so it's not autonomously running, and so we're still incurring a few costs, but we figure we're going to be at about $45,000. About 20 to 25% of that can be attributed to the fact that we wanted to run this as a class. And when you do that, you're doing many things twice, and plus you have an instructor fee and administrative fees. And so it would be lower had we not done the class, but we thought that was a critical component, and we had wonderful support from groups like Clean Energy Group and Solar Market Pathways to make that happen. In terms of the financial benefit to Hartley, we're looking at about $1,500 a year right now in terms of solar being up and running, the net metering from that, and also reduction in demand charges from what we can get from the battery system right now. And so if we were just to do that, kind of penciling out, it would be a 30-year payback. As Allison mentioned, however, we had a massive power outage and storm. In fact, 2 hours before this battery went into place and was put into the building, the power came back on after like 6.5 days. And so at that time, maybe before that storm, we were looking at this as a great project. Hartley was looking at this as a project that would put them back on the map, in terms of being on the cutting edge of energy and incorporating that into their education programs. But they weren't really looking at it as a really big source of revenue. The storm came, and they lost a week of camping classes, and that's one of their main sources of revenue for the nonprofit. That week that they lost was about $14,000 of lost revenue. And had they had power, they could have worked around all the other situations that the storm had. It was not having power that caused the loss of that income. And so immediately, the storm caused the view of this, the economic view of this installation to become different. And it became an insurance policy, and it became something that they really wanted done as quick as possible, rather than a kind of an interesting project to get their solar repaired. And so it really changed. There are, as Seth has said many times on different clean energy group webinars, the value of solar the value of backup is really hard to monetize, but we saw a very good example of that be monetized right in front of our eyes. And then the last thing in terms of value is, one thing that we think we have a very good chance of doing is moving Hartley from a demand tariff, where they have demand charges, to a non-demand tariff. And if we can do that, then we think we have the possibility of saving them close to $5,000 a year just by changing their billing. and then the project becomes under a 10-year payback. It will take a little bit of study. We probably won't know for another 6 months or so whether that's possible. We have to combine that with the other energy efficiency projects and the ground source heat pump repair that's going to be happening at the same time. But stand by. We think that will be a great demonstration of the potential value of energy storage if we can do that.
So we have a couple of next steps. As we mentioned, we're still waiting for some safety equipment that should be shipped by the end of the month to get the battery up and running. And we have a couple of students ready to go and look at the energy use of the building and play around with how the battery gets deployed so that we can work on this peak demand shaving and also just overall energy shaving for the building. Sunverge is currently working on this peak demand shaving software that should be available by the end of the year, so that will be exciting to load onto the battery and test out. Another thing is that we currently are monitoring the battery. Is connected with a 200 amp CT device for monitoring building usage. In the next month or so, we should be getting a 600 amp CT, which should be which is what we need to actually measure all of the building energy use. So right now we're just measuring one of the sub panels, which doesn't have the ground source heat pump on it. So we'll be able to more accurately schedule the battery once we have that 600 amp CT. So in the coming months, we'll be working on optimizing use of the battery. We'll be looking at equipment scheduling and talking with the occupants of the building on how they use different equipment in order to bring their overall electric usage down. We will be continuing, obviously monitoring the data, and one of the really neat things about the Sunverge battery that is great for a scientist and a researcher moving forward is the amount of data that you can get from the battery. I mean, their software is incredible. So we're really excited to play with that and see what we can do with it. And then also, obviously, we'll still be doing more educational outreach. We'd like to potentially hold another class once we, maybe in a year, once we have the battery optimized, and then we can show people how we're using it, what we did to make it work and minimize peak demand and overall building use.
And before I move on, almost done, before I move on to the next slide though, at the bottom of this screen, there is a small screenshot of e-gauge data, and you can see a point where there is no production or consumption, and that is a point where the battery is actually running autonomously. It was on August 26th when we had the commissioning, and the facility was islanded, and the battery was running the building along with the solar panels. So it's going to be it's a short picture that shows a radical change in our energy system, and it's going to be fun to have more kinds of pictures like that to show folks. In terms of tips for success or what we learned, one thing we really learned very quickly is really should determine the values of your clients prior to looking at economic project value, because as we talked about, the values of the clients in this case, the clients being the City of Duluth and Hartley Nature Center, they had values well beyond economic payback. They really wanted a resiliency value. They had educational values that were large. They really also wanted a platform where they could experiment with peak demand shaving. And so knowing that, we knew we didn't have, the payback wasn't as a critical feature for us. So that's important. Also, Allison mentioned we had an incredible advocate with Paul Elstrom, the renewable energy lead at Minnesota Power, helping us. Otherwise, we might have had an external disconnect switch, which might have been another $5,000 of cost of this project, and might have stopped it from going forward. We also had, in terms of a retrofit, if you have a technical advisor that can look at the system as a whole, I think that is key. This system went in 2003. No one had designs about how they did this. We were lucky enough to have our technical advisor be the person that supervised the solar installation back in 2003, and that made this project much, much easier. Chris LaForge is also excellent in terms of his overall knowledge of energy storage, and that was wonderful. And then Allison, I think, noted that flexibility is key. You don't have the building ideal building, you have the building you have, not the one you want, and so you have to adjust on the fly. So we've had to adjust where the CT was placed. We had to wait a little bit for parts coming in for a code adjustment that no one foresaw in 2003, and the parts weren't even available for it. So the part that's coming is one of the first off the factory floor. We have backup loads where they may not be the loads we wanted, but we can work with that over time. And so you have to be flexible and know what your overall goal is. And then I think having a holistic approach kind of falls into that, but we worked a lot with energy efficiency and systems operation, and in terms of getting this building to net zero, that's going to be as key or even more important than the energy storage system we installed. So at this time, we just want to thank you for letting us talk about this project, and we'd like to open it up for questions. Thank you so much.
Yeah, thank you.
Yes, and thank you, Allison and Brett. That was great. And I'm very happy to hear that Duluth now has a Solar and Storage Awareness Day. So hopefully other cities will join along. That's great. So we do have a number of questions. I would urge people to continue to submit them. We'll get to those that we have time to get to. Just to give people more of a sense of the size of the project and the size of the Nature Center, so we can put the system in context. Do you guys have an estimate of the square footage of the Nature Center? People were wondering, just so they know what size building we're talking about here.
We don't have the number in front of us, but it's in the 4,000 square feet area, 4,000 to 5,000 square feet, I would say, somewhere in that nature.
Great, thanks. So specifically, you were dealing with a building that was had been around for a while, but there's a question about retrofitting older municipal buildings. So I think we're talking much older, things like schools, senior centers, municipal centers, some that have probably been around for a number of decades. I would just say that I know that these same systems can be used in those, but obviously you guys ran into some distinct issues with retrofitting a project. They're much more difficult to do than a new project. Maybe just like to speak to that. I know Duluth is thinking about applying this to some other buildings. Do you have any insight into what types of buildings they're looking at and what the challenges might be in retrofitting some of their older building stock?
Sure. So I'll take the older building question first, because Duluth has actually some of the older residential building stock in the whole state of Minnesota, and so on the energy efficiency side, we see that all the time. In terms of energy storage, I think one of the key things that we identified would be something you really need to look at on older buildings, and that is your backup loads. Because as you do backup loads, you're getting into wiring of the building, and oftentimes that wiring is going to need to be updated. It's not up to code as you start to try to apply that to a backup load. And so it's one of those things where the value of energy storage should not be seen purely in its economic payback at that point, but at that point you're doing a capital improvement project on the building where you're upgrading its wiring at the same time. And so I think that would be an important thing to consider with an older building, assuming it may have solar on it at that point. I think the other question is Seth, what was the other part of that question? I'm sorry.
Oh, just really, I think you really addressed it. Just, can this be applied to older buildings? And just if you had any specific insight into that, which, I feel like you've probably pretty well covered it. Allison, if you have anything to add to that.
No, I think that's right. I think, the codes that you might all of a sudden now encounter when you're doing a retrofit, you need to be aware of. Because we definitely ran into that with the rapid shutdown and the arc fault protection.
Basically how it works with code is that if you are repairing a system, you don't have to meet new code, right? And repairing it as it was. If you're modifying a system, then new code applies. And so we modified this system, obviously, and so new code applied that was not in effect in 2003 for the roof array, and that's why we had to really work on making sure those codes were met. I think the other question you had was in regard to the city and where they're thinking about taking this, and they really they're very interested in terms of two features, resiliency, and they're interested in terms of peak demand shaving. Because as I mentioned, peak demand shaving is maybe 40 to 55% of their monthly bills from our utility. And so they are looking at one place where they've talked about potentially putting solar and storage would be on their public utilities building, which houses we have a municipal gas utility and other services within that building. And so it would be a resiliency feature if there's an emergency that could keep operating and also provide peak demand shaving. So that's one potential area they've talked about, but they're really interested in the research that's going to be done by UMD to see how broadly they can apply this technology and then potentially other storage technologies.
Great. And kind of a related question to this, just talking about public facilities. There's specifically a question that there's a project that they were looking in the early stages of developing a battery storage for peak shaving at a school in West Hartford, Connecticut. But they had their process shut down due to concerns about battery safety in a school setting. Was that ever an issue in your project development? And actually, I would like to just say that I do know that there are several schools in California that have installed energy storage for peak shaving. So this isn't an issue everywhere, but it is also an issue that comes up quite a bit. In New York City, they can't install lithium ion right now indoors because the fire chief has some concerns about safety in that kind of dense population center. So was safety a concern in your project? Did that come up?
It was a concern. I think it was a concern in the permitting side mostly. In Duluth, the fire department is not directly brought into this process, but that's as we move forward with research, we want to bring them in and show them what's happening in terms of energy storage, so that they have an idea of what they may be seeing a lot more of in the future. But on the permitting side, one of the advantages of working with the City of Duluth on this project and having them do the install is that then they could directly communicate with the Department of Building Safety in terms of what they were trying to do and answer questions directly. And so that was a concern of ours. Permitting was a concern along with interconnection. Those are two areas where we knew the project could get really hung up. And I think the advantage we had was that, again, we were directly working with the city, and then they had interdepartment communications rather than you having to maybe convince a reluctant inspector in that regard.
Yeah, and I would just add, Hartley is a preschool. The building is used as a preschool, a nature-based, nature outdoor preschool. They have over 30 3 to 5-year-olds in that building every day, and so in this case, we were able to move forward, like Brett said, without too many concerns.
Yeah, that's great. And I think Brett, you made a good point too. Of this is an issue that certainly has come up, if not to stop projects, it certainly can delay them when you're trying to figure out the permitting and interconnection late in the game. So getting that lined up and making connections with the utility early on are certainly very valuable for a project, so it doesn't overrun and just take forever to get done. So the battery system itself, as far as the way it operates, is there any special concerns with temperature concerns with either the system being too hot or too cold? Does it have built-in any energy controls? Does it have, I guess, on the fire side too, is there any fire suppression technology that's part of the system itself?
Well, the battery itself is in the mechanical room in the building, so it does have a temperature sensor in it, so that if it does get too hot or too cold, an alarm will go off. I don't know about fire suppression. I don't recall seeing any fire suppression inside the battery itself or inside the unit, but it does have temperature concerns, but it is in a ventilated room inside the building.
One of the things they often talk to you about that you can install it inside or outside, and in Duluth we really knew that outside wasn't an option for a battery, because in the wintertime we have days where the high does not get above 0. So we knew we were going to install inside. So that was one consideration for us. And in talking to SunVerge and other technical assistants, they all agreed that inside for this climate was better. So that's one thing to address. The mechanical room that it is in is a little warm, because there is other mechanical equipment in there. In the wintertime, it's in regularly 75 perhaps, where the rest of the building might be heated to 65 or things like that. So it's something we'll keep an eye on, but in looking at where we were putting it, we definitely, that was a point of concern that we worked through early with SunVerge and our technical advisors, for sure.
Great, and maybe you can speak to this. It's a question just on how the system is configured so that it prevents backfeeding to the grid. Yeah, I assume we're talking about in an outage situation when you can't have power feeding back onto the grid that could endanger line workers that could be out trying to reestablish the power on the grid.
Well, we did install an addition. So because this building, is older, well, a little over 10 years, I guess. And the utility was involved with the original installation of the PV system. They had an understanding where, like, if they needed to get in and disconnect the building from the grid, they would do that interior to the building. But in this project, we added an exterior disconnect switch that would now allow the utility to come and disconnect the building from the grid without entering the building. And I know there was several discussions, again, via our contact at Minnesota Power, about convincing them that there wasn't any way that the battery could accidentally feed electricity back onto the grid when things were disconnected. Yeah,
and there were additional disconnects installed interior, and then the rapid shutdown device and the arc fault protection that's coming will be connected to the exterior disconnect, and so you could actually shut down the entire system with the external switch at some point. So that was, in the end, what convinced the utility that what their concerns were being addressed. It was kind of I thought it was a very elegant solution that was put forward by Christopher LaForge from Great Northern Solar in terms of finding that particular product that could do that. And it was quite a search. He had to actually actively talk to companies that might produce it and convince them, a company that was producing it, that we could be a good beta test for that device. And again, that's the part we're waiting for. So yeah, sometimes there aren't always the technical solutions that we need for the problems that we have, but in this case, we really tried to make the marketplace provide it, I guess.
Great, thanks. And looks like we're just about out of time here. So we had a few questions that we didn't get a chance to answer. Apologize for that to those that have questions remaining out there, but we've got Allison and Brett's contact information up here, so I'm sure they'd be happy to answer any remaining questions. Or feel free to reach out to us at Clean Energy Group, and we can either answer them directly or get you connected to Allison and Brett. So thank you guys very much for presenting today. This is a really great project, and we hope to see more like them, hope to be hearing more from Duluth. So thank you very much for joining us, and thank you everyone for joining us today. I'd also like to let you know that we have a couple of additional webinars around energy storage coming up next week. There was groundbreaking at a project in Sterling, Massachusetts. That's a municipal microgrid. Very interesting project. This is also a resilient power project, much bigger level. It's part of a Massachusetts resiliency program. So on October 25th, we're going to have some more information on that. It'll be from 1 to 2:30 p.m. Eastern Time. We also have a webinar on October 27th from 3 to 4 p.m. Eastern. And that's on Massachusetts' new energy storage report that they put out. They did an extensive year-long study to look at the potential for energy storage in the state of Massachusetts, and had some really interesting results. There's potential for a lot there. So the key people that were involved in that report are going to go over what's in the study and what the next steps are for the state of Massachusetts. So Thank you very much for joining us. This recording will be sent around and will be available on our website, and hope to have you on another webinar soon.